So today we add and subtract rational expressions. This is where freshman year there were some issues and people ran into difficulty. Let's see if we can simplify it a little bit. So in order to add and subtract any kind of fraction, you need to make sure you've got common denominators. And there's three items that you must consider when you do this. You need to have a common constant denominator, a common variable denominator, and then a common polynomial factor denominator. And we'll go through each example and explain what each of these mean. So in this case, there are no variables, there are no polynomials, so we're going to need common constants. The constants are the 6 and the 4 in this case, and we need to find the smallest number such that both these go into it. We know that's 12, and we list a 12 down here and a 12 down here. And then we say, how do we multiply to get from 6 to 12? Well, we multiply by 2, but you can't multiply by 2 in the denominator without multiplying in the numerator. Thus, we've multiplied by 1 and not changed any values. So now we have 10 twelfths plus, and in this case we have to multiply by 3 in both the numerator and denominator, 9 twelfths, leaving us with, remember, we add the numerators and keep the denominators the same, so that's 19 twelfths. And we can leave it just like that. In this next example, you'll notice we have variables introduced as well as our constants, so we'll need common denominator of both the variable and the constant. I usually look at the biggest constant and use multiples of that to try to determine my LCD. I know 10 won't work, 20 doesn't work, 30 won't work, but 40 works because 8 goes into 40. So I'm going to write an LCD of 40 in both cases. Now with the variables, an x has to be in the LCD. Even though there's no x here, we have to have an x in the LCD, and we have to have a y in the LCD. So I list both of those. And again, just like in the last example and in all the examples we'll do today, we have to find out how we get from our first fraction denominator to our second fraction denominator by multiplying. So in this case I'm multiplying by 5 and then a y because I'm missing a y as well. So I multiply by that form of 1 to both the numerator and denominator, giving me 25y. And then in this case I'm missing a 4 and a multiple of x, so I multiply by that, giving me 28x, and we add these up. Typically they'll put them in alphabetical order, so that's 28x plus 25y, and at this point we would see if this factors, and if it does, factor that out and look to reduce, but this doesn't factor. We notice there's an x here and a y here, but they can't reduce because of this addition sign. You can only reduce across multiplication of factors and like factors. So now in this case, granted I have variables, but these are linked by addition and subtraction. So what that means is these are polynomial terms, and polynomial terms have to kind of stay as is. You can't split them up because they don't have factors within them. So in order to list the LCD, I need to list both of these. They're independent terms. So my LCD is x plus y and x minus y. Now the way I'm writing it, you might think I want to take and multiply those out, but I'm going to leave them as is. It's easier to see what to multiply when I do so. So again, I look at this denominator and say, how do I get from here to here by multiplying? I multiply by x minus y to both the numerator and denominator. And in this case I'm going to FOIL, so that's x squared minus xy. We add, and to get from this denominator to this denominator I multiply by x plus y. Again we FOIL, or I'm sorry, we distribute, and then we add like terms in the numerator, keep the denominator to the same. So in my denominator I have x plus y and x minus y again. numerator I have x squared plus y squared, and again we look to see if this factors. This is actually prime because I have a sum of two squares, so I'm done. No reducing can be done because I have no common factors to reduce. So here's a more complicated example. Basically the steps you want to go through every time when you have these complex examples is you want to see if anything reduces off the bat. Second, factor the denominator. Third, find your LCD. Then change your numerator. Spelled that all wrong. And next, add or subtract that numerator and then reduce if possible in the end. So in this case, we won't know if anything reduces unless we factor the denominator. So I'm going to go ahead and do that. I pull an x out of this and I have x plus y. This is a difference of squares, so that's x plus y and x minus y. And I look to see if anything reduces, no such luck. So now I have to find my LCD. And remember, I need common variables, common polynomial factors, and that's all I have in this case. I have no constants. So I'm going to need an x because this has an x in it. So I'll put an x in each term. I need an x plus y. I don't need 2 because this already has one in it. So I just need one x plus y. And since this term has an x minus y in it, I'll need one of those as well. And now every term in each individual denominator will go into this denominator. Thus I've created an LCD. You have a subtraction right here. So now I look to see how to get from this term denominator to this denominator. We can see we're missing an x minus y. So I'll multiply the numerator and denominator by x minus y, which means I'll need to FOIL in this case. So that gives me an x squared plus 2xy minus xy minus 2y squared. And then in this case, it looks like I just need an x. So I multiply the top and the bottom by an x, and I have xy minus 2x squared. Now this problem asks me to subtract. So the big mistake that's going to come in this problem is people are going to forget to distribute this negative to both terms. So what I have is I have x squared. I'm going to add these like terms while I'm at it. So it's plus xy minus 2y squared minus xy, and I'm getting all this from distributing, plus 2x squared over the denominator of x, x plus y, and x minus y. Clean up with like terms. I have 3x squared. The xy's go, and minus 2y squared. That's not going to factor, so I'm completely reduced in this problem, and that's my final solution. Let's continue some more examples very similar to that. Again, I look to factor. This will have an x squared in common, leaving me with an x minus y, or x minus 5, I'm sorry. And this has an x in common, leaving me with an x plus 5. There's no reduction I can do with the numerator and denominator, so now I need an LCD. Now in this case, you'll notice that the term on the left has an x squared in it. That's basically a variable term. This has just an x in it. In order for both terms to go into the common denominator, I need to make sure this x squared goes in. So I need not just an x, but I need an x squared in both cases. My x minus 5 has to be in my common denominator, as does my x plus 5. Next, we'll change those numerators. In this case, I'm missing my x plus 5. So I multiply by that form of 1 and get 2x plus 10. Second term, I'm missing an x and an x minus 5. So I have 2x squared minus 10x. Combine like terms, that's 2x squared minus 8x plus 10 over x squared times x minus 5 times x plus 5. And this is the first time where our addition yields a term that actually factors. Let's take a look. I pull 2 out because that's a GCF. And then I ask, is there any term that will take and multiply to positive 5 but add to negative 4? Well, 5 and 1 works, but it's not going to get me a negative 4. It'll get me a positive 5, but not a negative 4. So because I've completely factored that numerator and there are no common factors, I'm done. And I can just leave it like this. Certainly I'd take this answer over here, but I would get in the habit of factoring first to see if any reductions happen and then just leaving it like this. Next set. Once again, these 3's won't reduce because I have addition and subtraction, so I've got to go ahead and factor. That's x plus 2, x plus 1. You'll notice there are no common terms in the denominator, so I need each and every one of these in my LCD. It's x plus 2, x plus 1, x minus 2. And then I once again look from denominator to denominator, noting what's missing, and then multiply by that form of 1. So x minus 2 in the first term, and x plus 2 and x plus 1 in the second term, which is really this multiplication, so I'm going to list it as x squared, just makes multiplying easier, plus 3x plus 2 over x squared plus 3x plus 2, which is really that factored form down here. So I distribute through, and I have 3x squared plus 9x plus 6. Again, the trick, it's not really a trick, you just have to make sure you do it. Distribute the negative through. So I have negative 3x squared, negative 9 and positive 3 is negative 6, and negative 6 and negative 6 is negative 12. And that's all over my LCD of x plus 2, x plus 1, x minus 2. You'll notice there's a common term. I'm going to pull out a negative 3, leaving me with x squared plus 2x, and that's plus 4. Once again, it appears that although I've completely factored the numerator, there are no common factors left. Therefore, I can leave my answer like this. And again, since there were no common factors to reduce, I could have left my answer in this form, but unless I actually go ahead and factor it out, I'm not going to know if I get a reduction. So now in our last case, we take and factor these perfect squares. My LCD is going to be the combination of 2x plus 1 and 2x minus 1. I have three terms this time though, so I have 2x minus 1, 2x plus 1, and I'll list that 3 times. Have to go ahead and change our numerator again. So in this case, 2x plus 1 yields a 2x squared plus x. In this case, it's a 2x minus 1. Going to need to FOIL that. So that's 2x squared plus 2x minus x minus 1. And then this doesn't need anything. So once again, let's add like terms. We get 4x squared. There's 1, 3, 2, 0 x's, and minus 1 over 2x plus 1, 2x minus 1. And you'll notice in this case that 4x squared minus 1 is actually going to take and reduce, or factor if you will, to 2x minus 1 and 2x plus 1, and that's over 2x minus 1 and 2x plus 1. So in this case, our factoring has led us with like factors in both the numerator and denominator. Everything reduces and my answer is 1. So that's the advantage of taking and factoring your final answer. It may reduce in the end, and I don't think we ever would have seen that in the initial problem. So that's all we've got. Make sure you do your lesson summary and your Connect Ed, and we'll talk more tomorrow.